some knowledge, you can test the software. In the software, you can say the sine of 30 degrees, you got 0.5? Okay. So please remember that. When I was born, I couldn't even speak. Look at me now. You are all engineers. You are expected to know what a sine function is and what the sine of 30 degrees is, because these trigonometrical functions are used in the class. What is E? It's a number, right? What's a pi?
3.14.
Okay, what is the physical meaning of a pi? Okay, all right. If there is a cylinder, right, what's an area of a circle? Pi r squared. What if I give you a diameter? What's the equation for that? Pi d squared over 4. How many didn't know that? Okay, you learned something else. My point is that these quizzes are going to be done here, and you're going to get 15%. Oh, you're going to get 15% by just attending. Because I want to use this for your learning. All right, are you ready for this?
What's Friday?
You have set first day attendance. And this is such a waste of time, but I have to do it. You'll have a chance to listen to that. Days 2 to 350 in EDU 115. And the mandatory attendance is there. And in the end of the day, yes?
I have a different question, but it's about the next class. Actually, your next lecture, mechanics of
Let me
solids.
finish the first one. So attendance is mandatory. There are 2 wonderful TAs that you're going to do problems with. The way I see it is, I think very highly of myself. I'm also humble at the same time. In the end of the day, you're going to go out there and get a job, right? You can get a job right now. But it's your choice and your parents' choice to get higher education. Why is that? Because many people are afraid that AI is going to replace their jobs. No. The jobs are going to get replaced by the people that know how to use AI. It's not the AI itself, you know? There's a chalk right here. I wish there was a larger piece so I could show you an experiment. Maybe I'll show an experiment anyway. Does anybody have a paper clip? Only short pieces of chalk.
We got one.
A chalk or
Paper clip.
a paper clip?
Really funny to be so. Is that okay?
It's not about the shape. It's about the classes of materials. How many classes of materials do you know? Okay. Does anybody have a yes?
Isn't there like 7?
How about 54? No, I'm just kidding. What do you have there? Bottle of water? Water? Okay. Does anybody have a beverage? Nobody has anything with them? Okay. All right. Well, raise it up. Is that glass? Plastic? That's metal? That's plastic? Does anybody have a glass bottle? No, we don't have any. Oh, look, I found an earbud. It's yours, you can have it. Okay, bottled water, plastic. Anybody has glass? Oh, okay. So far, we looked at 3 water bottles. Plastic, polymer, metal, and the third one is glass. This through 3 bottles represents 3 classes of materials. What are they? Metal, polymer, yeah,
Ceramic.
ceramics, ceramics. Okay, those are 3 major classes of materials: metals, ceramics, and polymers. And metals, what I'm going to do to this fish is I'm going to twist it. I'm going to torque it to failure. Okay? You can see how many turns it takes, and it gets a little hot, and it's painted or it has a polymer coating on top. I don't know exactly what it is, so I'm going to see. How many times did I twist it already? But you see it still survives. Okay? My God. What, did I get another job here as a... My God! I'm doing my own next time. Holy shimoly! No, seriously, I've never... Okay. Okay, well, this is very interesting. It's very interesting to me because I think that this coating here is a polymer coating. This piece here is actually steel. And I want you to look at the fracture surface. Okay? And pass it around. How did it fail? On what plane? I'm going to try to do this with chalk, but I don't know if we'll be able to because it's not long enough. Oh! Look at that! Give me a like. I want you to compare how this failed. Okay? Here. And pass it around. Compared to that. How many twists did I do the metal? Too many. How many twists did I do this? Okay, the next class that you have a question, I didn't forget about you, is going to answer the question as why it happened the way it happened. But this class is also going to answer this question of why it happened the way it happened. The way it happened is because one material is brittle, this material is brittle, and that material is ductile or moldable. What's your question about the next class mechanic?
It says on the actual class registry it's in the engineering building, but on your syllabus it says it's in the chemistry building. Some people were just confused on where it was actually like going to be.
Did I screw up? As usual. Hold on. Chemistry 1, oh shit. END 118. Well, thank you that you told me. Yeah, I had it backwards. END 118 is better or not than Chemistry 101. Okay. Yeah. I'm a human after all, and I make mistakes just like AI. Thank you for bringing this up. Any other questions? Yes. I think so. Yeah.
Oh wait, oh never mind. That's for a different class.
I know they scheduled them back to back. I tell you, like my bodily functions depend on it. Actually, the other way around. Any questions about the syllabus thing? There's a schedule here, spring break. Are you looking forward to the spring break? Yeah.
Actually, no. Because is it full class?
Why this does not work?
It's 2:30 to 1:45, so another 15 minutes. But how long is it?
Okay, yes,
For exams, how long are the exams? Is it like the full class or you extend it?
the exam?
Yes.
The exam is gonna take the full class. And you're gonna bring your laptops here and hope internet connection is powerful enough to handle it. I don't wanna deal with cheating, anti-cheating software. So at least when you're gonna be here, you're gonna know that you're not gonna be talking to other people. You're gonna be solving those problems, and each of you are gonna have their own numbers. Okay, so the exams are gonna be here in person.
So full time. And you mentioned we use a cheat sheet, or that's for quiz?
Yeah, you can use a cheat sheet, just piece of paper, you write all the formulas. I mean, yeah.
Right.
The more formulas you write, the more you're gonna remember. Yes?
So how do you manage it? Do you do like a split of multiple choice and three response, or is it all three response?
It's gonna be a homework problem set that you're gonna do here in class. Yes? No, but I always do it in the favor of a student. Okay, so I do not legally announce the pluses, but if I have to use them, what's the passing grade for this course? Is it a C? C plus? I grade on the absolute scale, which means that all of you right now have an equal chance of getting an A. If you get 90 plus, was it 90? You get an A. You realize that if you just show up and listen to me, then you're going to get 15% on your quiz. It's a good thing.
So quiz is this week.
How much do you pay for the concert? Your parents? I'm just kidding. I can do the song in 2 clicks, but it has some issues, so I'm not going to do Spanish again. Although the English I have no problem with. Are you having fun studying? No? Why? It's not fun? Yeah? Why would you do that? Memorize stuff. All I want you to know is that the sine of 30 degrees is 0.5. All I want you to know is that the elastic modulus of steel is 200 GPa. All I want you to know is that the elastic modulus of true solid is like more than 1 GPa. All I want you to know is that the elastic modulus of diamond is how much? More than 1. 2? 1,000 GPa. I had a student, he came up to me, he said, I just measured the elastic modulus of silicon carbide film of 3,000 GPa. I said, yeah, let's go get a Nobel Prize right now. I want you to know that the theoretical strength of the material is 1/20th of the elastic modulus. It cannot be higher than that, because if it is higher, there's no material that can withstand 50 gigapascals of stress. It does not exist. It would break. It does not exist. So you can calculate. Do you know Disco Stew? Who is Disco Stew? From The Simpsons. What was Disco Stew doing? Everything. Like projecting the what? The sales of the disco records that were going up and up and up and up. And it just never happened. So
At least
I can only triple your salary, don't ask for more. I got some inside things with Meta, with whatever, $2.5 billion for the news. Okay, why are materials important? Because we study the relationship between structure properties of materials, and we develop new materials. Look around. I'm a material boy living in material world. It's a great song. Okay? We all consist of,
Materials.
and cells consist of, and matter consists of, and molecules consist of atoms. Here we go. Okay, so the atoms from the dinosaur are in all of us. I mean, there's conservation of matter, right? Have you taken chemistry? Are you Breaking Bad? No? Chemistry is great. The prerequisite chemistry. Luckily enough, this course is very simple because we treat atoms as balls. And the balls are ping pong and tennis and basketball. That's all there is to it. That's all you gotta know. Anybody play basketball? I used to play tennis. The reason I'm standing in front of you right now is because they took me to university. And the physics graduate student brought a bowl of liquid nitrogen. And it's like funky looking because it's, fumes. And he takes a tennis ball, and I used to play tennis. He puts a tennis ball in this nitrogen, you can imagine, and it's floating. And then he uses a glove and glasses and protective gear, and he drops it on the floor. What happened to that ball? Shattered. And I was amazed. Because, tennis. I've never seen the inside of the ball because believe it or not, tennis balls were subject to expert control. I came from the Soviet Union. They did not allow American tennis balls in Russia, Soviet Union, in Moscow. Anyway, I'm quarter Polish, so I love Krakow. Ja rozumiem po polsku, tak. What I just described to you is called ductile to brittle transition. Liberty ships, Second World War, they were made by welding. Before they used rivets. The rivets, if there's a crack, the crack would arrest at the next hole and not propagate further. But to make those ships faster, they welded them. And for the weld, there's a continuous propagation path for the crack. They deployed those ships one time, it was cold. In the morning, the ship cracked in half. If you ever go to the port of Tampa, there's a Liberty ship right there. 25% of those ships have cracks. Materials, yes? No? Okay. Materials change their properties as a function of temperature. Temperature has very strong effect on the properties. Most of those properties have exponential temperature dependence. It means E to the power. How many logs can you have? Type of logs. What about a natural log? What's the base of a natural log? Okay, and the notation is Ln, right? What about Lg? Not the washing machine. What's the base of that? 10. In other countries, maybe in Spanish-speaking countries, it's Log, not Lg. Is that right? You don't know. Okay. Yes? Okay. The same thing for the tangent function. What do you write here? TG? No, you write TAN. You see? So never mix US dollars with American pesos because the exchange rate fluctuates. Okay. We are going to create products from existing materials and we're going to develop processing techniques. Many USF students work for Apple. You know what they ask you for Apple? In Apple, they tell you, here's a piece of aluminum, and we need to bend it 180 degrees in one processing step. How many of you have an iPhone? How many of you have an Android? I have both, but okay. I only carry one with me. What's the case made from? Titanium X15. But it's from Korea, so I have a physical SIM card. Does WeChat still work here on campus? You don't have WeChat, but somebody has WeChat. It works here? They unbanned it? Do you remember TikTok was banned? Yeah. Okay. Do you have any questions? How do I make it big? Do you know? Press this. It doesn't work. Yeah, and how's that helpful? And if I click close, it's going to close. And I have action. Download it. And I download it here. And now, what did I press? F11? Yeah. Look at that. How do I get rid of this? I can't. Okay. All right. How many of you like the movie Ice Age? Yeah. Is that a class of materials? People used to call chunks of time in the history after a material. Stone Age. Bronze Age. What age do we live now? AI? Silicon? Stone Age, Bronze Age, Iron Age. Nanomaterials. Polymers. Have you seen this movie, The Graduate? Plastics. Dustin Hoffman. It's an old movie. I heard the RAM is super expensive. When was the last time you built yourself a computer?
I know about.
Huh? Not too long?
I know about computers.
2021, that's long. It's like that thing is obsolete. Anybody play computer games? Okay, so you need a powerful computer for that, right?
Oh wow.
Polymer age. Why are you here? Go make some money. What are you doing here? Okay, the products, devices, components that engineers design are all made of materials. Really? Okay, they're all made of materials. To select appropriate material and process techniques for specific applications, engineers must have knowledge of material properties and understand the structure-property relationships. Process structure properties. Process. So in front of it, there's process. The structure. Do you understand properties? No? We're going to study properties. Mechanical, electrical, optical, magnetic. What other properties? They're like electrical, that's electrical. Does anybody know Ohm's law? What does that mean? What's an Ohm's law? Ohm's law. Okay, if I give you a multimeter and I ask you to measure the voltage in the outlet, how would you do that? AC volts and give a range. What range? Okay, in the States, one phase, 110, 120. Okay, and you put it in like this. Find the neutral. It's AC, bro. It doesn't matter. It's oscillating a current. I'm not talking about DC. I'm talking about AC, not outlet. Okay. I was 11 or 12, I think. And then I decided to measure the current. I measured the voltage. It was 220. Right on. I had a military grade, like, nice multimeter. And that's how I learned the Ohm's law. Why are you laughing? You've done the same? No. What if you are to measure the current? How would you do that? Yeah, you have to put it in series. What does that mean? You don't even know what it means. You know. I know. There are two types of electrical connections. Parallel and series. Parallel is, here's your source, and here's your plug, and you plug it in like this to the source. And the series is when you plug it in between. So like, if I grab, I get electrocuted, but if I pass it through me, I also get electrocuted. It doesn't matter for a human body. But what I did is I took that nice multimeter and I took those two contacts and I put it on the amps, because I know that current is measured in amperes, and I plug it in. What happened? What happened? I'm still here. I'm still alive. It did. And the circuit breaker went off. And it smelled bad. A little burnt. And then I took it apart. And then there was a metal piece with a ball that would keep the dial in place. And that metal piece melted in half. So what did I measure? I measured the current of a short, which is, based on this formula of the Ohm's law, is infinity. So there you go. How many of you live in a house or apartment? Okay. How many of you know what a circuit breaker is? What is it? Off of electricity. What does it do? Have you ever blown your circuit? Okay, you can turn it off and on, that's a good thing. What happens when it turns off by itself? What did you do? Or you overload the circuit, right? How does it work?
Too much.
It's got a trip. How does it work?
Fuse.
Fuse? When was the last time you had to replace a fuse? You just go in there and flip it back off. I remember when it was like a fuse, but yeah. What? Relay. Not really. A bimetallic spring. A bimetallic spring. Okay? Let me explain. There's one piece of metal and there's another piece of metal. And when you pass the current through this metal, it heats up. Yes? And when it heats up, it expands. And one expands more than the other and breaks the circuit. So the principle is electro materials mechanical. And that's why you can use it again versus a fuse. Okay. The $200,000-$300,000. I have 4 more minutes. This is it. This is it. See? Hardness. If this one is 100. This one is 200. This is a 300. And whooping $600,000, $500,000 you can make. It's the same exact material. When was the last time when you could have such a boost in performance? What are your hobbies? What do you like? Besides this. Fishing? Okay. What do you use for fishing? Rods. What are those rods made from? Bamboo. I use bamboo. No? Okay. Anybody else? Any hobbies? Surfing. You have a surfboard. What's that surfboard made from? Plastics. What do you make sure that you're not sliding off the board? Okay. Yes?
Weightlifting.
Weightlifting. Okay.
I suppose the barbell is probably some kind of.
Have you seen this guy who pretends to be a janitor?
Yes. Yes, I have.
When I used to be in shape, I would do handstands in the end of the class. But yeah, look at me now. Fishing. I tried that in Oahu, North Shore. That was the one and only time. Yeah. It is crazy because the wave was very high, and I had no idea what I was doing. I couldn't go through the breaks because I didn't realize, and then, you know, the guard came up and said, "You don't know what you're doing. Don't go in the water again." I'm happy to be alive because the wave just pushes you down and you cannot breathe. You cannot breathe, and then my PhD student was a diver. He used to dive. That's another thing, right? You can have decompression if you go down. What happens when you go down? Pressure high, pressure high. How many of you have gone climbing in the mountains? Can you boil water in the mountains? You can. But what temperature does it boil at? Depends how high you are. I can tell you that if you get high enough, it's not going to boil at 100 degrees, so you cannot use boiling of the water as a disinfection method. And that's what we're going to talk about. We're going to talk about phase diagrams. We're going to talk about matter and fuego, or whatever was the matter. Okay. Any questions or comments? Are we going to have fun?